Hey Algebra 1, here are the notes for 9.4 day 2. So we learned how to factor quadratics with a non-prime leading coefficient. So now can we also solve these equations, aka can we take it one step farther? So the first step remains the same as it was when we were factoring. We still need to set it equal to 0 so that we know we're working with it in standard form. Over here, you'll notice I messed up on my variables. That is actually supposed to be an a. So now I'm going to move everything to one side and get 12a squared plus 5a minus 2 equals 0. Once it is all equal to 0, we are going to factor the same way that we did in the previous lessons. And our final answer is going to look like this. It's a product that is set equal to 0. I'm going to use the X box for this just because that's what we've been doing. Remember, in the top, we're going to have a times c, which in this case is going to be negative 24. In the bottom, we're just going to have b, which is 5. From here, do those factors. 1 and 24, 2 and 12, 3 and 8, 4 and 6. How do we get a positive 5 out of those numbers? Well, an 8 and a 3 paired up will do it. If we want a negative 24 but a positive 5, we're going to have to make the smaller number a negative so that a positive 8 and a negative 3 sums to a positive 5. Remember now we have to rewrite this as 4 terms so that we can factor by grouping. I bring a down. I notice it has more, in my opinion, in common with this 3. So I'm going to say negative 3a plus 8a, bring the c down, and still set it equal to 0. You need to section that off. Remember now we're going to factor by grouping. So first we factor using the X puzzle, and then we factor by grouping. I notice these both have a 3a in common. I'm left with 4a minus 1. These have a 2 in common, so they have a 4a minus 1. These are still set equal to 0. I'm just not going to keep bringing that 0 down for right now. Factor out the 4a minus 1. I'm left with a 3a plus 2 equals 0. Once we have it set up as a product, we can use the 0 product property. And just as a reminder, that says that a times b equals 0. So either a or b has to equal 0. So 4a minus 1 equals 0, or 3a plus 2 equals 0. We've worked with this extensively up to this point. So I'm going to assume that once we've set it equal to 0, we can solve and get a equals 1/4, or a equals negative 2/3. Once we've used that 0 product property, we're going to solve for our variable. And we should have a final answer of x equals some number, or a pair of numbers. So we're used to everything up until this point. From here on, we're still used to this. We've just never used it with this type of problem. So I'm not going to go super in depth with these, but I will show you 2 examples. I think the first one's pretty self-explanatory. So remember with this one, we're first going to start by moving that negative 11x over. Remember, we have to write it in standard form, so the 11x has to come after that 2x squared if we want to use our X puzzle. All right, X puzzle it up. I'm going to do it down here. We get negative 80, positive 11. Let me think on that one. I believe a 5 and a 16 multiply to 80. A negative 5 and a positive 16 will add to that plus 11. Now we're going to rewrite it as 2x squared plus 16x minus 5x minus 40. Factor by grouping. Once we have our factors, we set them each equal. So I either get x equals -8 or I get x equals 5/2. Same thing here. I'm not going to go all the way through this problem, but I will show you that we need to move these over first. So it becomes 8x squared minus 7x plus 5x minus 3. Now you might be tempted to right away try to start factor by grouping. However, you're going to very quickly realize you cannot do it. So we need to simplify this down into 8x squared minus 2x minus 3, and then use our x puzzle just as we have been. All right, there's plenty of videos out there if this one wasn't nearly long enough for you. Let me know if you have any questions.